Now the principal root causes some other problems. And if you're ever simplifying an expression with these roots, and you have an even root of an even power, so let's take a look at a couple of those. How about the square root of x to the fourth and the square root of x to the sixth? And the result is odd. So the resulting power is odd. So if I take a look at the square root of x to the fourth, it's just going to be x squared. But the square root of x to the sixth is x cubed. So you can see here I have an even index, an even power, and an odd result. When you see that happen, you have to take the absolute value of it. So the reason for that is, let's take a number like -2 and plug it in to both of these expressions. So the square root of -2 to the 6 is the square root. What is -2 to the 6? -2 to the 6 is 64. And the square root of 64 is 8. Okay. Oh, I'm doing that behind my video there. Let me move my video down for a second. All right. Now, I saw the equivalent expression, and if I just kept it as x cubed, that would mean I would have -2 cubed. The problem here is -2 times -2 times -2 equals -8, which is not the same number. These two numbers don't match. So how can they be equivalent expressions? Well, the only way we can do that is by making it absolute value. And the absolute value of -8 is +8. Now they match, and now we have equivalent expressions. So that's the reason why we have to keep track of this. So even root, even power, odd result, absolute value. And you just have to do it for that part of it. So, example 2, simplify using absolute value. So here I see I have an even index and even power. And the fourth root of y to the fourth is y to the 1. Now we have ourselves an odd result. So since we have an odd result, we have to put it in absolute value. So we say this is equivalent to the absolute value of y. That's all we're doing. Sixth root of 64 times the sixth root of x squared minus 3. And 18 can be written as 6 times 3. So you can see I've got a power that I can cancel out there. 64, the sixth root of 64. What is the sixth root of 64? Oh, it's 2. I don't even know why I took a second here. Now, for this first part of the problem, I don't have to worry so much about the absolute value. Because I'm taking the principal root, there's no negative in front of it. I don't have to worry that that's a thing. So I just write 2 as my result there for the sixth root of 64. But here, when I cancel this out, you can see the resulting power will be odd. And I had an even index and an even power that I'm factoring out. So, times the absolute value of x squared minus 3 to the third power. And there is my solution. Of course, you don't have to write the little dot there for times. You could just write 2 times the absolute value, and it would be the same thing.